From the shore, an observer measures the angle of elevation to the top of the Golden Gate Bridge to be precisely 38.362 degrees. The same observer moves 500 feet back and measures the angle of elevation to be 27.346 degrees. What is the height of the bridge? Here's some interesting facts about the Golden Gate Bridge, which is located in the Bay Area. So the color of the bridge is actually not red. It's actually called International Orange. And people are continuously painting this to protect the bridge's steel from rusting. The length of the bridge is approximately 1.7 miles long, and at one time it was the world's longest suspension bridge. If you ever have the opportunity when you're visiting San Francisco to go to the Golden Gate Bridge, it is just beautiful, especially when the sun is rising or setting. You can walk across the bridge, you're able to rent bikes and bike across the bridge, and you can even take tourist rides on boats that go underneath the bridge and learn all about the history. I've gone ahead and constructed a rough graph that I've gone ahead and modeled the information that was provided in this word problem. X represents the height of the Golden Gate Bridge. It says the observer, and here's our horizontal line, measures the angle of elevation, that's to the top of the bridge, to be precisely 38.362 degrees. The observer then moves back 500 feet, remeasures the angle of elevation to be 27.346 degrees. So we probably are going to have to determine what is this length in order to be able to precisely calculate the height of the Golden Gate Bridge. Let's start with this initial triangle. X is opposite, N is adjacent to this angle. And I know that the tangent is going to use those two measurements, opposite over adjacent. Now I'm going to put my calculator in terms of degrees. Let's make sure that's the case before I get started. It is. And I'm going to approximate this. We're going to go 4 places past the decimal. So the tangent of 38.362 is 0.7915. And now let's isolate for X. So we're going to cross multiply. I have 0.7915n is equal to 1 times X, or simply X. Now let's create a secondary equation. And in this secondary equation, we're going to use the fact that we know that when the observer moved back 500 feet, we have a new angle of elevation. So a tangent of 27.346 degrees is equal to opposite over adjacent. Now the adjacent is 500 plus this unknown length. Just like I did in the previous part, I'm going to figure out what is the tangent of 27.346. And I'm going to round that again 4 places. Let's isolate for X once again. And set it equal to 1x, or X. Now it's time to distribute 0.5172 to both quantities on the inside. I'll grab my calculator once again, taking this amount times 500, and then taking it times n. You can see I have 2 statements in which X has been isolated. So what I'm able to do is I'm able to take this quantity, which is equivalent to the same X we spoke about up here, and I can replace X with this quantity. It doesn't equal 1x, it equals what X is, which is 0.7915n. All right, let's go ahead and let's solve for n. So I'm going to move over 0.5172n to the opposite side. I'm left on the left-hand side with 258.6. I'm going to grab my calculator. 0.7915, subtract their like terms, 0.5172. And now to isolate n, we're going to divide both sides by this quantity. Okay, So N is approximately 942.76. But that's not my final goal. That's this length right here. My goal is to know what is the height of the bridge. So what I'm going to do is I'm going to recreate this triangle. I know that this length right here is the unknown. And I have a couple different ways that I could achieve the final answer. I'm going to go ahead and stick with the smaller of the two triangles. Now, what is this length? We didn't know initially what this length is. Now we know this length is 942.763. So again, opposite and adjacent. The tangent of 38.362 degrees is equal to opposite. I'm creating that ratio, opposite over adjacent. And in order to solve, if I move this up, in order to solve for this unknown length, which represents the height of the bridge, I'm going to multiply both sides by 942.763. Okay, x is now by itself, and I can plug this into the calculator. 942.763 times the tangent, make sure you are in degrees, tangent of 38.362, and this will represent the height of the bridge. So the height of the bridge is 746 feet, 746 feet, 0.2. So let's see if we can put that into just a little more precise terms. So if you only had to write in terms of feet would be good, but I'm going to take 0.2. I know there's 12 inches in 1 foot, so this is approximately 746 feet and 2.4 inches.